Hello, let's take a look at your MT3 LT1 seminar in conjectures and counterexamples. Do the first 5 questions and then come back and check it. We'll go over those in class. What we're going to look at today is we're going to write and analyze conjectures using inductive reasoning. We're going to disprove conjectures by using counterexamples. First off, in inductive reasoning definition, it's where we base a conclusion on a pattern. This is what scientists do. Okay? That is, they do an experiment and they come to a conclusion. And then what happens is they make their hypothesis. And then somebody else does it. If it confirms that, they're saying, oh, there's a pattern going on here. For an example, I know in my car, when it says E, I've taken it 40 miles and not had to fill up. So my pattern is when it gets E, I got 40 miles before I have to fill up. It's not good for your engine to do that. My guess about my rule is called a conjecture. So if we ask you to state a conjecture, that's what it is. It's a guess about a rule. Now if we take a look at example 1, I want to write a conjecture that describes this pattern, this sequence. And I want to use my conjecture to find the next term in the sequence. So the first thing, if I notice, it goes 8:30 to 9:45. That goes up by 45 minutes, doesn't it? 9:15 to 10, 45 minutes. 10 o'clock to 10:45, 45 minutes. So my conjecture is going to be that the appointments are 45 minutes apart. So what comes after 10:45? Well, that be my next appointment would be 11:30 then, wouldn't it? Now, if I look at example 2, let's look at something more mathy. I want to make a conjecture about the sum of the squares of 2 consecutive natural numbers. Well, think about what the heck am I talking about when I say consecutive natural numbers. Consecutive means next to each other. Natural numbers are numbers on the number line, whole numbers. No negatives, no decimals. So if I pick like 1, I'm going to square them. So 1 squared plus 2 squared. That's 1 plus 4, that's 5. Let's go like 3 squared plus 4 squared. Well, that's 16 plus 9. That's 25. Let's try another one. Let's go 9 squared plus 10 squared. That's 81 plus 100, 181. I'm going to rewrite that 181 for you. And notice my pattern here. If I look at those numbers, notice they're all odd, aren't they? So my conjecture is when you add the squares, I'll say, plural, of consecutive numbers, say whole numbers, how about that? The answer will be odd. The thing to remember about a conjecture is it's a guess. Not all guesses are going to be correct. So when a scientist does something and then somebody else does the experiment and they get a different result, then they say, oh, your conclusion was not right. In order to show a conjecture is true, you can't really show it for inductive reasoning. You have to prove it. Either show why it must be true or go on forever and show that you've done all possible cases. If you find something that isn't true, that's called a counterexample. You only need one counterexample to show it's false. You need infinite examples to show it's true. So let's take a look here. My conjecture is if n is a real number, then negative n is negative. Well, you think at first, you're thinking, hey, that's true. Because if I go 1, negative 1 would be negative. But what about 0? 0, the opposite of 0 is 0, isn't it? So there's my counterexample. I just found a number on the number line, because that's what a real number is, that when I take the opposite, it's not negative. I could have picked another one, like, for example, what is the opposite of negative 4? Well, the opposite of negative 4 is 4. That's not negative, is it? There's my two counterexamples. If I look at letter B, it says, hey, if I got these two angles are congruent, then they must be vertical. And I can just show that really simple. Here's angle ABC. And over here, I'll have angle DBE. They're both congruent, but they're not vertical angles, are they? So what happens is when you're asked to show a counterexample, you show the first part is true, but not the second part. So for example, on example A, I showed that a number on the number line, sorry about that, I'm trying to get my highlighter here, okay? My number on the number line, that's true, but the conclusion is not true. Here, I've got two angles, they're congruent, but they're not vertical. So I met the first part, but the second part was not true.